Welcome. In this video, I'm going to finish going over the functional groups as well as the third rule for putting together the name for any organic molecule. So amine is the first of the three groups containing nitrogen. And amine gets its name from ammonia because ammonia is NH3. So amine's just NH2 because you need to remove that third hydrogen and allow it to bond to a carbon group. So amines can occur in the center or on an end carbon, either one. And then amides are slightly different. It just means that now you have an NH2 group, but it's bonded to a carbon that also has an oxygen double bonded to it. And so instead of being called an amine group, it's called a carboxyamide group because it's got both the double bonded oxygen and the NH2 group. And so I remember that the amide has the D in the middle because it has two groups, which is like diamide, and then also to remind me that the oxygen is double bonded to the carbon along with the NH2. So again, that would leave a single bond for that carbon, which means amide groups are going to occur at the end of a carbon chain because there's only one bond left to connect it to the other carbon. A nitrile group, and my formatting didn't show through here, but this should be a triple bond that you're seeing here. So nitrile is carbon with a triple bond, and the name tells you it's triple bonded. Nitrogen, triple bonded, and then connected to the carbon atom. So this also has to be on an end carbon. So some functional groups, what you have to note of is that some functional groups can only be bonded to the end, and others have to be bonded to an inner carbon, and some can be bonded to either. So we have to somehow indicate where is the functional group on that carbon backbone. So the carbon's position is determined by counting, or is designated by counting from the shortest end to that carbon. And there's two acceptable ways to indicate which carbon number it's on. Americans tend to place the number of the carbon before the name of the compound, such as 2-pentanol. But internationally, it's often shown by inserting the carbon's number into the name with dashes just before the functional group, such as here we've written pentan-2-ol, but we'd still pronounce that as 2-pentanol. Now, even though that looks confusing to look at, the nice advantage of that is that it's recognized internationally, and it also is clear about what your functional group is. It's very clear that the OL is determining what you have there and that it's an alcohol. So either system is fine. So either way you write the name, as I mentioned, you pronounce the name by saying the name first. So showing you two examples here, 1-butene or 2-butene. And also, just so you know, if there's only one position possible, like butanoic acid, the COOH has to be on the end. And so there is only one place it can be. So carboxylic acids you typically don't put a number in front of because they're always going to be on the first. But like with propanol, the ketone, again, because ketone has the oxygen double bonded in the center carbon, because there is only one center carbon, I wouldn't have to designate this 2-propanol. If you use the number, it's not going to be a deduction against you. So then rule number 3, how do you identify side chains or substitutions? So if you have branches or some kind of substituent off the carbon backbone, you have to name these branches. And if it's a carbon side chain that's branching off, then you use the prefix methyl, ethyl, propyl, butyl, etc. to show how long that carbon length is. But be careful that you're actually looking at a branch off the longest carbon backbone. So be sure you've identified your longest carbon backbone and you're truly looking at branches off of that. If it's an element that's substituted, quite often they're halogens, so then we just call it fluoro, chloro, bromo, iodo. Or it could be a functional group. Two common functional groups that show up in other families are both the amino and the hydroxy group. And then the other thing to consider is there more than one of the same side chain, and what's the position of the side chain, which carbon is it on? So we use the numbering to show which carbon it's occurring on, and then if there's more than one of the same side chain, we use the prefix di, tri, tetra to show how many there are. So for example, and I want to make a quick correction here, this has to be 1,2 because 1-methyl isn't possible. So 1,2-dichloropropane, propane means there's 3 carbons. And I was having some trouble getting my carbons to right there. So 1,2-dichloral lets me know that there's a chlorine here and a chlorine here, and then the rest of these are hydrogens. And I'm not going to draw all those hydrogens in, but that's 1,2-dichloral propane. If it said 1,1,1-trichloral propane, then I know that I actually have 3 chlorines all on this N carbon, on the first carbon. And then finally, 1-chloral-2-methyl is letting me know that I've got 1 chlorine on the first, and then on the second group, I have another carbon branching off with its 3, sorry about that, with its 3 hydrogen attached as well. So notice you use commas to separate numbers and prefixes. You see the commas up here where I've used them. And you use a dash to separate numbers and names. So prefixes would be like if I had, well, I can't think of an example right offhand of where you would have a prefix that you're using the comma on. Oh, right here, I see one. So 1-chloral, 1-methyl, or between the numbers, and then you use the dash between the numbers and the actual name. And then side chains are listed in alphabetical order, so the chloral comes before the methyl, not numerical, although in that case it's both alphabetical and numerical. So to sum up, there's 3 possible parts written in this order and 1 single word for the name. You have the prefix, which is showing the position, number, and name of any substituents or side chains. There's the stem, which shows the number of carbon atoms in the longest chain. And then there's the suffix letting you know what family or what functional group is being used. So here's a couple I'm going to draw for you. If you had 3,3-dimethyl-butanol, so what I look for first is my stem. Butanol is letting me know I've got 4 carbon atoms. So 1, 2, 3, 4. The Al is letting me know it's an aldehyde group. So that means there's an oxygen and hydrogen off the N carbon. And then the 3,3-dimethyl lets me know that 3 away from that functional group, there is a CH3 group, and in fact there's 2 of them. So then my other hydrogens will go here, and you should actually draw in all your hydrogens when you're drawing these for any summative assessment, but you get the idea. You go ahead and fill in all the hydrogens there. And then 1-chloral-2-methyl propane lets me know it's 3 carbons. The A and E lets me know they're just single bonded. The 1-chloral-2-methyl lets me know it would look like this. And that would be 1-chloral-2-methyl propane.